Hi, I'm Joe Rodriguez, a Market Development Engineer here at the Design Verification Technology Division at Mentor Graphics. We're here to talk about ModelSim Essentials. ModelSim is a very capable tool. This is a brief tutorial about ModelSim Essentials. This video will introduce key concepts for workflows that enable you to become proficient at validating your design. A brief introduction, a conceptual overview. I'm going to talk about debugging, which is a very expansive topic, but I'll distill it down to a few key tools. Talk about code coverage and automating simulation. Let's start with an introduction of ModelSim PE. ModelSim is a verification and simulation tool. It was created to be a true native compiled mixed language simulator with rapid adoption of standards so that our user community can leverage the full efforts that drive the creation of standards. We engage users' inputs and every release has improvements, so it's easy to understand how our user base continues to grow. We refine our use models, documentation, and have excellent support. And the concepts I will talk about also apply to QuestaSim. Well, every tool has technical information, whether it's release notes, installation notes, things like that. We have a very rich environment, and we use what we call the Info Hub to present the simulation information about all types of topics. It's a web-based interface to our knowledge base. Quick searches for topics point to relevant topics. The same information is also available in PDF form and also via command line with the -help option to our commands. So for instance, vsim -help will provide all the options for the simulator command. In order to help us teach new customers to learn our tool, we continue to offer and maintain our tutorials. Our tutorials have been created with the same commitment to mixed languages that our engineering department maintains. In order to effectively practice techniques, we provide VHDL and Verilog examples so you can practice in your native language. We will leverage the ModelSim tutorial to help introduce the most common and most useful parts of the tool. Everything from basic simulation, debug tips and tricks, and also code coverage, which is now part of ModelSim PE. Why use the tutorial? Because we've invested in creating examples of common tasks for your native language. It's included with every release. And one aspect of hands-on learning that should not be overlooked is the ability for the teacher to enable continual learning. Our tutorials also have, for each lesson, a list of related material. In this case, it's how do you reference design libraries, how you use Verilog and System Verilog for simulation, is also VHDL simulation, and referencing the actual commands that were used in a particular module. So it's not just for practicing with the language, it's learning what else is available that is relevant to the topic. If you have a question, use the Info Hub to ask for answers, or search directly in the Command Reference Manual PDF. The Command Reference Manual is an excellent resource for example use modes. Learning by example is fundamental. You may find yourself creating a desktop shortcut to this manual like I have. There are two main methods for managing your environment: the traditional command-driven workflow and a graphical user interface-driven project workflow. We will also talk about how to manage the most complex simulation environments, so that once you've determined a workflow, you can then manage and add to that workflow. Let's begin with the basic simulation workflow. First, you create a library, then you compile your design, then you load and run simulation. And if you're like most people, you end up debugging the results of your simulation runs. So the first step is creating a work library. All design files are compiled into libraries. Typically, you start by creating a work library called Work. It's the default name. The ModelSim library is compatible across all platforms and also across releases. And they're HDL design language neutral. So in one work library, you can have Verilog, System Verilog, VHDL, or System C. That's a work library. And this is also part of the advanced topic where we talk about managing more complex environments, generally associated with multiple work libraries. The next phase is compiling your design. Our compilers have file-based syntax checks, and all direct their results to a work library by default named Work. Each compiler has specific options for the language, like what IEEE standard the compiler should check when parsing a design or test bench file. The next part of the flow is loading and running simulation. You invoke the simulator, vsim, with a top-level working Verilog module or VHDL entity. You can invoke with multiple tops if you architected your environment this way. ModelSim, the command name vsim, generates native x86 code when loading the design. we have a significant investment in ensuring the native code generation is optimized for the operating system and microprocessor's machine code. Once you have loaded the design, you can begin to stimulate the design with your test bench or through command line stimulus, or both. Of course, ModelSim has very many options for debugging. We will introduce the rich debug environment, but now we want you to practice the basic simulation flow with Chapter 3 of the tutorial. Optionally, you can review the project flow that I will introduce next, if you would rather drive simulation via the graphical interface. So let's talk about the two workflows, basic simulation flow and the project flow. So the basic simulation flow is command-based. It's flexible, allows you maximum control of your environment, and consistent with QuestaSim. Chapter 3 introduces the basic simulation workflow, practicing the workflow in your native language with both VHDL and Verilog available. Now the project flow allows you to come up to speed without having detailed command line knowledge. It's driven through the graphical user interface. Chapter 4 introduces projects and allows you to use the Verilog or VHDL workflows so you can practice in your own native language. Some of the things that the project workflow does for you is it simplifies the interaction with ModelSim. You don't need to know the intricacies of the compiler switches and library mappings. It eliminates the need to remember a conceptual model of the design. The compiler order is maintained for you in the project file. It also removes the necessity to reestablish compiler switches and settings for each session. These are stored in the project metadata, as are mappings to the source files that allows users to share libraries without copying files to a local directory. There are other advantages for using a ModelSim project file, a .mpf file, that's also described in the Chapter 4 called Projects. As I mentioned, you will eventually find a need for having multiple work libraries in your environment. This is what we've called building a complete simulation environment. Most environments contain third-party IP, reuse of your design files or libraries from other projects. Maybe it's FPGA behavioral, ASIC, or FPGA gate-level models with timing, or perhaps it's a microprocessor model that you may want to run code against. Chapter 5 will allow you to practice creating and using multiple libraries. You can learn how to use the ModelSim.ini to reserve and preserve those library mappings that make the environment portable from one environment to the next. You can create mappings to as many individual libraries as you need to accomplish your verification tasks. So we've talked about the overview, basic simulation, the module-based workflow. Eventually you'll end up having to debug your design. We have a very rich environment, but I will introduce some of the basics of analyzing waveforms, debugging with the graphical data flow window, viewing and analyzing memories, and comparing waveforms. These are very highly productive endeavors. Since ModelSim supports so many different tasks, from behavioral to gate level simulation, code coverage analysis, and reporting, and so many debug techniques, we have relied on the multi-docking interface to provide a flexible user interface that can be tuned to a particular operation. This MDI interface is very comprehensive and allows you to manipulate your environment for these tasks. There are different windows that can be placed in any position and can be grouped together with any other window. You can see this one on the left, the library and simulation tabs. Those would be tab groups. Now the objects window in the middle illustrates the drag handle, the part in the middle that you can grab and move around the interface, or you can zoom, undock, and close with the toolbar on the top right of each one of these tiled windows. This interface is common across all the windows that we employ to help you accomplish your verification with ModelSim. Over the years, we've also built more descriptive icons. Different colors represent different languages, different shapes represent different object types. The squares equal scopes, circles are processes, colors also mean something. Light blue is Verilog or System Verilog. We also know that dark blue is VHDL, and the optional simulation capabilities of System C are in green. And even though we don't support the assertions or cover directives in ModelSim, for the sake of completion, I also implemented or showed you that PSL is a magenta color. In addition, you can see that icons in the wave window and all the other windows also have significance. So the diamonds equal signals, diamonds with arrows indicate ports and directions. So you can know, for example, if TXDA is an input or an output, RxDA input or output, all by just looking at the descriptive icons. This is one of the main themes of the interface, is put as much information so that you can debug things without having to do research about what you're actually trying to debug. We're going to highlight the most common debug tasks so you can get started deploying your next project with ModelSim. The first one, and probably the most common, is the waveform debug flow. ModelSim MDI interface allows cross-linking of windows so that it makes it easy to add objects from one window to any other. You can have context sensitive, so if you're looking at a particular part of your design hierarchy, all the other windows are relevant to that particular design hierarchy. We also have cross-linked simulation time, so if you have an active cursor, you can see the values of that active cursor in other windows. The actual waveform window itself has the ability to find the next rising edge of an object. You can save and reuse waveforms, for instance having a golden waveform set, so you can use waveform compare. And really the best way to learn how to use some of the capabilities of the waveform window is by using Chapter 6. So you can practice using the graphical user interface to debug with the waveform window. And again, we deploy VHDL and Verilog versions so you can practice in your native language. So to augment debugging with waveforms or source code window with annotation, we also have a graphical interface so you can explore the connectivity of your design. You can trace and identify the cause of the events, for example chasing an unknown. You can sprout to one or all levels of the hierarchy, either forward or backwards, and again they're all cross-linked. Also there's an embedded waveform window, so the object you select, the waveforms for that particular object you selected in the data flow appear in the embedded waveform, and that can be toggled on and off as well. Referring to Chapter 8, debugging with the data flow window, it allows you to practice navigating the connectivity of your design in your native language. Another useful tool is debugging with waveform compare, which allows you to easily identify differences between two unique waveform data sets. Identify the first and all known divergent values very easily. For example, if you have a known good waveform and you've made a change to the RTL and you have a failure from your test bench, you can use waveform compare to identify the first divergent value between the two data sets. And that way you can start debugging from the first miscompare or any of the miscompares that you may want to. Generally, the first divergence is the place where you'll find the root cause of all future bugs, but not always. So you can use the waveform compare wizard, or you can modify all the parameters to put tolerances on the leading edge or on the trailing edge of values. So it's a very, very comprehensive capability, but most people can get a lot of their jobs accomplished just by using the waveform compare wizard. And we'll walk you through that wizard in Chapter 11 of the tutorial comparing waveforms. As I've mentioned before, we're continually adding capabilities to ModelSim and QuestaSim. One of the unknown technologies, I think, is that we have this ability to view and analyze memories. So that way you can view 2D memories, you can initialize them, you can change them as the simulation is running, you can save them and use comparisons similar to the waveform compare capabilities. And this is all automatic. In the process of creating work libraries, we do automatic extraction of the 2D memories for Verilog and VHDL and present them in two key areas. One is the memory list that's generally part of the structure window. You select that tab and this window contains all the memories that have been extracted for that design hierarchy. And then if you want to, you can select one of the memories that you see here in the memory list window. As you see here in the data window, it allows you to view the results as the memories are getting filled or written to. And you can also, like I mentioned, you can preload them or change the values through the graphical user interface. You can learn how to do this in Chapter 9 of the tutorial, Viewing and Initializing Memory. Code coverage is part of every one of our simulation products. It truly is automated, so all you have to do is compile your design with coverage options on, and then simulate with them on as well. And then we automatically extract coverage information as you're simulating your design, and not only extract that information, but allow you to view the results and easily identify what you have to actually exercise in order to stimulate that line of code. So as you can see for this one example here in this screenshot, that there is a state machine start op state that has not been yet exercised by your test bench. In this way, you can easily identify coverage holes and analyze what you need to do to accomplish stimulating that area of your design, in this case a state machine. It's native, just turn it on. and easily identify untested portions of your design. As I mentioned on the previous screen, we not only collect coverage information, we have effective coverage analysis tools to show you what state machine variable has not been exercised, or what case statement has not been seen, or whatever it is in your code that's not been stimulated. Code coverage is low impact during run and compile times. In addition to its low impact, it has a comprehensive simulation database for collecting and reporting results. And we all know you can't improve what you don't measure. So it's really simple to enable coverage, run it, and analyze what kind of holes you have. If your management is tracking your projects, you can report on progress so that as you are working towards your verification goals, it's easy for management to see that progress. To realize how easily it is to simulate and analyze your coverage results with code coverage, we've included Chapter 10 of the tutorial so you can practice in your native language for Log or VHDL. So we've covered a lot of ground in terms of ModelSim essentials, and I hope you have taken time to review the interesting parts of the tutorial so that you can gain the valuable practice that's needed to become very productive. So if you've done that, the next thing that you'll eventually want to do is start automating your workflow. So aside from exercising a couple of the pre-existing do files in the previous lesson, ModelSim has a very interactive mode, executing single commands one after the other via the GUI, the menus, or the main window command line. In situations where you have repetitive tasks to complete, you can increase your productivity with do files. Do files are scripts that allow you to execute many commands at once. The scripts can be as simple as a series of ModelSim commands that you ran through the exercises, with associated arguments, or they can be full-blown TCL programs with variables, conditional execution, and so forth. You can execute the do files from within the GUI, or you can run them from a command line prompt without ever invoking the GUI. This is one of the main methods for batch type simulation. You run a suite of tests, accumulate coverage results, merge the coverage results together, and then analyze the coverage holes for the entire regression suite. So you can learn how to do this in Chapter 12 of the tutorial, Automating Simulation. So I want to stress again that the tutorial is a very excellent place for you to learn the tool and become more productive more quickly. So a recap. The Info Hub is your simulation library. Access it through the GUI in the Help menu. You have a very comprehensive resource here. You can search for a keyword that you may have seen in the warnings or errors that come from the transcript window. You can also see the PDF bookcase, which has a similar, if not all, the same information. Release notes, user's manuals, command reference, and again the tutorial that I've stressed that you should be using with its examples. So thank you for learning how to effectively learn ModelSim together with your tutorial. You have a solid infrastructure to draw from, so you can be successful in your design verification tasks with ModelSim PE. There are learning opportunities beyond our product-based infrastructure. I highly recommend the Verification Academy for expanding your knowledge of verification. Self-paced technical training by industry experts, things like code coverage, functional coverage, VHDL 2008, System Verilog classes, UVM classes, really endless opportunities for learning how to improve your verification IQ. Thanks for learning how to use ModelSim effectively in your next project.